Okay, so now I'm going to introduce the five-step process. And what I want you to keep in mind is that this five-step process is going to be necessary at first, but after you become proficient at looking at cardiac rhythms, then this five-step process may not be completely necessary. For example, people that have been diagnosing rhythm strips for a number of years or over a period of time, they're able to look at the EKG strip and pretty much determine exactly what it is just by glancing at it. But at the beginning, this five-step process is going to be necessary. So this is the five-step process. And these are the 5 questions that you have to ask when looking at each individual rhythm. Is the rhythm regular? It's a yes or no answer. What is the heart rate? Are there any P waves? Measure the PR interval and measure the QRS complex. It's pretty simple, the 5-step process is. Now, whenever you look at this, keep in mind, like whenever you're looking at the heart rate, you can determine from that whether a rhythm is fast or slow. Looking at the P waves, there only should be one P wave for every QRS. If there's more than one P wave, it's not normal. If there's no P wave at all, it's not normal. The reason this question is being asked is that there are rhythms that have more than one P wave. Also, there are rhythms where P waves are non-existent. So you need to go through these 5 steps. When it gets to the QRS complex, if the QRS complex is greater than 0.12, that's an indication that the rhythm could be ventricular in nature. But again, make sure to go through the 5-step process. Measure the R to R waves to see if the rhythm is regular. If the R to R waves are irregular, then you know that it's an irregular rhythm. Look at the heart rate. Okay, now one of the easiest ways to determine heart rate is to look at a 6-second strip. And the only thing you have to do is count the number of R waves, or to count the number of QRS complexes, and multiply it by 10. That's really easy to do. And that will give you an approximate heart rate. It may not be exactly on, but it will be approximated. Now, you can do these more complex ways to determine heart rate, but you can also look at the top of the EKG monitor and it'll tell you the heart rate as well. Now, one thing that I want to caution everybody about is just because you have EKG complexes, that does not necessarily mean that you've got a heartbeat, because you have to remember the EKG represents electrical activity, and there should be a mechanical response that follows. There are situations to where a mechanical response does not follow. This is why you have to assess the patient, not the monitor. If a patient has an EKG rhythm, you can look and see what the rate is on the rhythm, but to know that the patient has a heartbeat, you have to assess a pulse. Are there any P waves? Again, there should be only one P wave for each QRS. The other thing is that all P waves should be identical in morphology, in size, shape, and position. The P wave should not be behind the QRS. There should not be more than one. The P wave should not be notched. Each P wave should look identical. The P wave in beat 1 should be the same or look the same as the one in beat 2, 3, 4, etc. And the reason this is important, and this is an important question, is that there are rhythms where there are notched P waves. There's rhythms to where there's more than one P wave. There's rhythms to where there's no P wave. There's rhythms to where the P wave is behind the QRS complex. So that is why you have to answer this question. Again, measure the PR interval, and we know that it should be between 0.12 and 0.20. Measure the QRS complex, it should be less than 0.12.